Hi guys, welcome to an other episode of MrLopezClasses.com. This is the chapter 12 of your marine electronic book. In this chapter we are going to start to talk about the connectors, the cables, the NMEA connectors, the NMEA cables, and we are going to start to talk about the topology used to connect and to create the backbone, the NMEA backbone, the expressway, in order to connect all the equipments in the central expressway. All right, we are going to start right now with the chapter 12 dedicated to the NMEA backbone. Okay, the most important part is be clear about the quality of the NMEA cables, the quality of those wires. Those cables are specified for the network, and those cables they meet requirements related with impedance and propagation. This is very important. The impedance, the resistance, and the delay of propagation. And those cables normally are working with a DC power. Okay, we are going to follow those standards. Okay, the NMEA 2000 cables use a trunk, sometimes called backbone, and this is the trunk or backbone, and those are the drops lines. Those are the drops lines, and this is the trunk. The NMEA 2000 cable include 5 wires. 5 wires like you have right now on the screen. 1, 2, 3, 4, and 5. 2 of those wires, the white and the blue, are for signal, and 2 wires, the black and the red, for power, and the bare cable is to drain, is the draining to ground or bonding. 2 cables for power and 2 cables for data. Okay, the specifications of the NMEA cables. In NMEA cables, we have 3 types of cables. I make a mistake in the slide. Please, there are 3 types of cables, and the cables are mini cables, micro cables, and mid cables. Mini cables, micro, and mid cables. And right now we are going to try to understand what is the difference and in what scenarios can I use one of these, and in what cases I need the other one. For what reason one cable is better than the other one, depending of the situation. Okay, the Open Device Vendor Association, ODVA, is the standard for cables and connectors for automotive, robotic, and special environments, including the IP67 and the NMEA 2000 standards. Okay. NMEA mini cable. We are going to start with mini. After that we talk about the mid cable, and we are going to finish with the micro cables, and we are going to verify where are used each of those cables. Okay, the mini cable is commonly used for trunk, for the backbone. The backbone use the mini cables in general, or networks. Because those cables have a capacity of 8 amps. Okay, right now we are going to introduce the first magic number, 8 amps. 8 amps. In this backbone, in this expressway, should be no more than 8 amps. Yes, it's a little, but this is the maximum amount of amps that should be moving across the backbone and the drop lines. No more than 8 amps. For that reason, we are going to use fuses at the input when you supply the power, in order to introduce more than 8 amps. What happens if you introduce more than 8 amps? Immediately all the screens on the computers, the temperature increase dramatically, and immediately you have a code in the main computer, and the code says attenuation or high voltage, and suddenly the system stops for high temperature. The 8 amps the consumption in amps, 8 amps, should be mandatory. This is the most important part. In the expressway, no more than 8 amps. Okay, the mini cables are used to create the trunk, to create the backbone, because those cables administrate around 8 amps. And the micro cables are excellent for trunk lines, for drop lines, because they only administrate 4 amps. For that reason, I did that summary in the bottom. Mini cables for trunk, because they draw 8 amps, and micro cables for drop lines, because they move it 4 amps. Okay, this is the most important part. I want that you keep in mind that information. Other information is related with the mini cables. The mini cable, the external diameter is in between 0.41 and 0.49 inches, and the maximum bend radius is 7 times the diameter of the cable. You can bend those cables 7 times the diameter of the cable. Alright, and right now we are going to check the mid cables. The mid cables are the biggest in diameter. They are the biggest in diameter, and those cables have the less voltage drop. The less voltage drop in the system are the mid cables. In other words, those cables are used when you have equipments where the voltage drop is an important factor on the performance of the equipment. But in general, the configuration of the backbones is with mini cables on the trunk and micro cables on the drops. Mini on the trunk and micro on the drops. The mid cables every day are less used. The majority of the configurations are with the mini in the backbone and micro on the drop lines. Okay, the diameter of those mid cables is 0.33 inches, and this cable is commonly used for smaller networks. Let me explain what is the advantage of this mid cable. If you have a small boat, center console boat, with one outboard or 2 outboards, you can create the backbone in a small backbone like this, with 4 drop lines. All of those cables, mid cables. That's it. This is good for small boats, for small lands, when you can use the same cable for the trunk and the same cable for the drop lines. The mid cable in that particular case is excellent. What is the recommendation when you use those cables? Be careful with the connectors, be careful with the T's, with the elbows. Those elbows, those connectors should be compatible with the cable. That's the most important part. Okay, my friends. And now we are going to continue with the micro cables. The micro cable is a typical cable used as a drop line, connecting devices in order to maintain the truck line with an outside diameter in between 0.24 and 0.28 inches. The micro cable has the smaller diameter, for that reason is more flexible, and you can bend those cables 7 times the diameter of the cable. I mentioned that situation before. Okay, right now we are going to talk about the connectors. There are millions of connectors, different type of connectors. The most common is the T like this. With the T, you can organize different T's in order to create like a connector bus bar, with more than 2, 3, 4, 5, in order to connect a bus bar. You can use a bus bar like this, connector bus bar like this, or you can connect 2 or 3 T's together in order to create a bus bar similar to this one. That depends of your configuration, depend of the space that you have, because normally when you connect T's together, you need more space. If you are working in a small boat, like a center console boat, and you don't have a space, probably those bus bars are excellent. You found a bus bar like this, female and male, like the bus bar that you have on the screen right now, male and female, and of course you have this like this with one end female, the other one male, or all of them male or female. You have different configuration. You also found elbows, like the elbow that you have in the screen, or connectors, straight connectors. Yeah, that's all of those should be compatible with the cable that you are using. Once again, for small boats, I recommend, if it's a small network, I recommend use mid cables. If it's a medium or big boat, I recommend the backbone in mini and the drop lines in micro. Simple. Okay, and now let me explain what happened internally with the cables. I explained before that the cables internally, they have 5 terminals. The majority of those cables, they have 5 terminals. 2 terminals for data, the white and the blue. 1 terminal for the drain, and the black and the red are for the power, the DC power coming in. Alright, the mini, mid and micro cables contain 5 wires. 1 twisted pair, red and black, for the power. 1 other twisted pair, blue and white, for the signal, and 1 drain wire, bare wire, in order to drain excessive interference, excessive noise, and excessive current. The following tables show the color, the name, and the usage of each wire containing inside of the cable. Alright. And mini and micro bulk cable. Yes, you can buy bulk cable in different lengths. 10 feet, 15 feet, 25 feet, 50 feet, in order to create the backbone. Be careful with this, because right now we are going to talk about the maximum distance in between the beginning and the end of the trunk, of the backbone. The maximum distance are 250 for mini cables and mid cables, and 250 meters, and 100 meters for micro cables. The total distance of the backbone. Right now we are going to repeat that explanation, and we are going to be clear in those distance. Okay. In order to connect properly all of those elements in the backbone, we are going to use the appropriate cable, the appropriate terminals, and we are going to start and finish with terminal resistors. Those terminal resistors. I have a couple of terminal resistors here. Terminal resistor like this. One at the beginning, other at the end, in order to close the loop of the information and avoid like a ringing in the loop. Because internally in this expressway, the information travels in one direction and travels and return. If you don't have the resistors, the information never returns. Those resistors are used to return the information and complete the cycle of the movement of the information. Remember, in this expressway, you have different protocols depending on the equipment, and moving all the time over there. The protocol of the radar is here, the protocol of the GPS is here, the protocol of the radio is here. All of the protocols are over there, and if you don't have properly installed terminal resistors, the information never returns. We are going to talk later about the terminal resistor and the function of the terminal resistor. Other important information is the protection of those cables, that shield. That shield is used to prevent that the radiomagnetic interference in the area affect the cable and affect the data and affect the information. This is very important. And this cable, the drain, is basically the drain to ground in order to drain noise, interference, and other critical factors. Alright, and there are different type of connectors with different type of protections. Those type of connectors with metallic end are more expensive, and they are commonly used when you have equipments with audio and video connected into the system. Those connectors are excellent for those systems. The regular connectors like this, or like this, they are in plastic. This is marine grade, waterproof. When the system is properly tied, the humidity not enter. But they are not expensive. You buy those terminals in any marine shop suppliers. Right now, West Marine, Jerry's Marine, Pacer Marine, a lot of companies dedicated to produce electrical and electronic devices. They supply cables, mini, mid, and micro, and terminals, and terminal resistors, and terminal bus bars. All of those toys, you can buy those toys in any marine supplier. All right, we are going to continue with the connectors. Like I explained before, there are connectors in elbow like this, or connectors in T, like the connector that I showed to you before, male and female, and different adapters in order to create the backbone properly. All right, there are cables with 4 pins. In general, the NMEA cables have 5 pins, but there are cables for 4 pins. Those cables for 4 pins are the cables normally used to connect computers and engines into the backbone. Okay, in general, the NMEA connection of the majority of generators, engines, to the backbone is with cables 4 pins. What is the meaning of that? They only use 4 pins in order to enter over there. Remember that in the backbone you need 5 pins, 2 for data, 2 for power, and 1 for drain. Probably those cables, they drain it through the negative of the engine, through the negative of the generator. They don't use the drain of the backbone, and they only use 2 cables for data and 2 cables for power. The cable for data, the blue and the white one is for send information, and the other one to return the feedback. It's exactly the same like the AC power. You remember the hot and the neutral. One is the output and the other one is the input. The return is similar. Okay, the flow of data is through the cables blue and white, and the flow of power, 12 volts or 24 volts, is through the red and the black one, or red and yellow one in some cases. Okay, those 4 pins connectors are exclusive for computers, and some GPS antennas, they use 4 terminal cables. If you check in the back of the computer, the connector, you have the picture on the screen, the connector for the antenna, the GPS, is with 4 terminals. Alright, my friends, and now we are going to check the connection of the T's. Like I explained before, you can connect the T's in series like this in order to create bus bars with more outlets in order to connect more equipments. It's possible. Okay, and this is the typical backbone with the power supply. The power supply is basically 1 T like this, and on the T like this. On the T at the end, you have the positive and the negative to be connected into the backbone. I have an example here. This one, in this backbone, I have 2 sources of DC power. One source in the middle, coming from the DC panel. One source in the middle, coming from the DC panel. And other source at the end. When you have a long backbones, the recommendation is 1 source of power in the middle and 1 in each end, at the beginning and at the end, in order to keep the voltage stable, equal in the backbone. The voltage drop is other critical factor that we are going to talk right now, and we are going to calculate how much should be the maximum voltage drop in order to avoid one inconvenience on the computer, and the light is Attenuation is because the voltage drop is more than the recommended 1.5 volts. Right now we are going to talk about that. Okay, in this particular example, because it's a short backbone, I put one source of power in the middle and other one is at the end. And each source of power should have one terminal negative and other terminal positive. And the positive terminal should be protected with a fuse, and the fuse in this particular case 4 amps, and other fuse for this one 4 amps. What is the idea? Never introduce in the backbone more than 8 amps. For that reason, I protect this source of power, the positive, with one fuse, and this source of power with other fuse, in order to keep the backbone with 8 amps. This is the maximum allowed amount of amps in the backbone, 8 amps. Alright, the sources of power, you can, normally the color for the sources of power is yellow, like the picture that you have on the screen, and the T to connect the power should be yellow, or any type of T, but the cable is different. The cable is red with black, okay, or red with yellow. Those are the sources of power. In a couple of minutes, I am going to explain the possibilities for the sources of power. Those are the cables in order to enter the power. But we are going to talk later about the sources of power. And because we are going to use 2 different sources of power in order to introduce the power in the backbone. Okay, my friends. Now the terminal resistors. The terminal resistors are critical elements in the construction of the backbone. 2 terminal resistors are required on every NMEA 2000 network. One on each end of the trunk. Normally, a male resistor is used since male pins tend to point back the power source. Yeah, this is the typical terminal resistors. Those terminal resistors should be located at the end of the backbone, and is mandatory. If you don't have a terminal resistor installed in one of the ends, the signal is not traveling, and immediately you have a code on the computer indicating that one additional terminal resistor is necessary. In other words, the backbone is a linear element, and each end should be finished with one terminal resistor. That's critical. This is mandatory. Okay, and there are cables with 8 pins. Those cables are not common. Normally, those cables with 8 pins are used in a harness of engines in order to connect engines into the backbone. But if you check internally in those 8 pins connectors, normally they have 3 terminals not used, not connected. In other words, they can replace those cables for 5 pins. For that reason, the new technology, the new engines today, the majority they comes with 5 pins cable terminals. Alright, and the female and male connector, like I explained before, you founded the T's with 1 terminal male and 2 females, or 2 females and 1 male, and in order to extend the trunk or reduce whatever you need, and according with the space that you have in your boat. I have a picture that I want to share with yours. This is a nice picture. This is the typical backbone in a boat, and this is the central backbone. 1 terminal resistor here, other terminal resistor here. Look at this, the source of the power in the middle here. This is the connection for power. Look, this is the power connection. This is the typical connection for power, and you have drop lines. 1 drop line for this instrument, other drop line for the radar, other drop line for the display, other drop line for the laptop, other drop line for the transducer, other drop line for other transducer, other for the compass. All of the equipments are connected in the central backbone, and the central backbone is moving the information back and forward. If you check the trunk, the backbone travels from the back of the boat into the front of the boat, and you have the options to connect the rest of the equipment into the backbone. And right now we are going to talk about the maximum distance of the backbone, the maximum amount of equipment that can be connected into the backbone, the maximum voltage drop, and the maximum separations. Right now we are going to talk about that information. Okay, those are examples of in this picture. This is males, this is females, bus bars, and those are the connection with T's, 1 T, 2, 3, 4, 5, 6 T's together. And this is other example of 1, 2, 3, 4, 5, 6 T's together, and the terminal resistor. If you check in this picture, this is a small center console board. This is the backbone. Look, the terminal resistor in one end, the terminal resistor in the other one, and 6 terminal for 6 equipment. That's it. This is for a small boat with one radar, the GPS, 6 equipment, and this is for a small boat. Alright, and there are ports with females in one side and males in the other side. This is nice. Yeah, there are different options, and you found it in the market today, a lot of options from different manufacturers. Okay, my friends, right now we are going to start with the creation of the backbone and the recommendations related with the voltage, related with the intensity, related with the amount of devices, maximum amount of devices connected into the backbone, related with the maximum distance, and we are going to follow those protocols. Okay, connectors and network is possible if all the equipments talk the same protocol, NMEA 2000 or NMEA 183. Alright, and right now we are going to start to talk about the different type of topology. There are different type of topologies, but in marine application basically there are 2 topologies commonly used, and the most common is one of those topologies. Right now we are going to explain. The general topology of a NMEA 2000 is known as a trunk and drop, or backbone and drop. The NMEA 2000 backbone is connected in a continuous linear form without branches, forks of loops or loops. Okay, let me continue. And those are the most common topologies used in order to create the backbone. The way in which the connections are made is called the topology or a computer network. 4 most common technologies are bus, star, ring, and mesh. Network topology specifically refers to the physical layout of the network, especially the location of the equipment and how the cable is running in between those elements. Alright. All the devices in a bus topology, are connected in one single cable. When one computer sends a signal up, all the computers on the network receive the information, but only one accepts the information. This is the bus topology. Alright, let me continue with that topology. When the signal reaches the end of the wire, it bounces back and travels back up the wire. When the signal echoes back and forth along the unterminated bus, is called ringing. In order to stop the signal from ringing, attached terminals at either end of the segment are necessary in order to absorb the electrical energy and stop reflection. This is the function of the terminal resistors, and you have in these pictures those terminal resistors at the end of the bus topology connection. This is the bus topology. Those are the advantages and disadvantages of the bus topology. Advantage: the bus is simple, reliable in a small network, easy to use, easy to understand, require the less amount of cable possible, and is easy to extend. Those are the advantages for the bus topology. Disadvantage, when the traffic is heavy, probably the system goes slow. Each barrel connector, weak energy and weak performance. It's difficult to troubleshoot in a bus topology. Yeah, those are some inconveniences. The star topology. The star topology is the most common topology used in IT departments in hospitals, universities, banks, in the financial industry. They use a star topology. All the cables run from the computers to the central location, where they are all of them connected by a device called hub or router. You remember? Okay. The star topology, the hub can be active or passive in the star network. Active hub regenerates the electrical signal and sends it to all the electronic devices connected to the system. The passive hub doesn't amplify or regenerate the signal and does not require electrical power to run. Okay, advantage and disadvantage. Advantage is easy to modify and added new equipments. Center of the star network is a good place for diagnosis or troubleshoot. Single computer failure do not necessarily bring down the whole system. Several cable types can be used with the same hub. Disadvantage, the central hub fails and all the system fails. Many star networks require a device at the central point to rebroadcast or switch the network traffic. Is more costs, more money. For that reason, in the majority of the boats, the topology is a bus topology, and the majority of the marine application, the electronic marine application, you found it a bus topology because it's reliable, it's easy, and is easy to troubleshoot. Believe or not, the people say that in bus topology is more difficult, but I don't think so. In this particular case, in marine applications, I prefer a bus topology. Alright, and this is the typical NMEA backbone. This is an example of, this is a transducer, this is the fuel sensor, the marine instruments, the source of power, the chart plotter or main screen, and this is the backbone. Alright. The construction of the trunk line using double end core sets connected between T's or tabs. One end of the core has a male connector with the male pins, while the other end of the core set has a female connector and female receptacles. Yeah, we are going to talk right now about that situation. Okay, the backbone. The connectors are keyed to the backbone, and they can only be connected to each other in one way. As an alternative, the double end core set, you can make your own trunk line using ball cable and field attachable connector. Right now I am going to explain what is the meaning of that. Okay, my friends, look at this. Look at this. Maximum cable distance. We are going to calculate what is the maximum distance of the trunk. And we are going to start basically checking how much is the maximum distance depending on the cable that we are going to use. The cable distance between any 2 points, a point being an electronic product or terminal, must not exceed 250 meters or 820 feet for a system based on mini or mid trunk cables. And the maximum distance should be no more than 100 meters or 328 feet for systems based on micro cables. Okay, I make this summary about this. The maximum distance for mini and mid cable should be 250 meters or 820 feet. For micro cables, the maximum distance should be 100 meters or 328 feet. Okay, what is the meaning of maximum distance? Is the distance, the linear distance in between both terminal resistors. This is the maximum distance between both terminal resistors. Okay? For most cases, the maximum distance should be measured between terminal resistors. However, if the distance from the trunk line T to the farthest device connected to the trunk line is greater than the distance from the T to the near terminal resistor, you need added. Okay, let me explain that situation. Okay, the maximum distance should be the distance between this point until this point in between both terminal resistors. Okay, if the drop line of any equipment is bigger than the distance, if this drop line is bigger than the distance in between the T and the terminal resistor, you need added this distance in the total maximum distance calculation. Once again, if you found one equipment with the distance bigger, the distance in between the equipment and the T bigger than the distance in between the T and the terminal resistor, you need added this drop line into the total distance calculation. In other words, the total distance is the distance in between each terminal resistors plus the drop lines if the drop line exceeds the distance in between that T and the closed terminal resistor. We are going to do an example right now in order to clarify that situation. Alright, in this particular case, in this picture, the 5 meter drop line, this one, look, this one, 5 meters, should be included in the maximum cable distance, since the drops are longer than the distance from the T to the terminal resistor. That distance is smaller than this distance in between the T and the equipment. For that reason, in the calculation of the maximum distance, we are going to include this one. Okay, let me explain in other example that situation. Okay, before of that, one important thing. If I added all the drop lines, all of them, this plus this plus this plus this plus this plus this, should be no more than 78 meters. The cumulative of all the drop lines should be no more than 78 meters. One important information, important question. The cumulative drop line length refers to the sum of all the drop lines in the cable system. This sum cannot exceed 78 meters or 256 feet. That's a very important information. Okay, in this particular example, look at this. In this particular example, we are using 4 drop T's, really R5, and 2 multiports. This is one multiport, and this is the other multiport, similar to those, no? Multiport bus bars. 2 multiports and attached to 11 devices to the trunk line. Let me I check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 devices. 11 devices added to the trunk line. Okay, the cumulative drop line length is 37. Let me check. I have 2 meters here, 2 plus 4, 6, plus 5, 11, 11 plus 3 is 14, 17, 19, 22, 24, 25, 25, 29, 31, and 33, and 37. Perfect. I have 37 meters in total. Yes, you need added this plus this plus this plus this plus this plus this plus this and this, in total 37 meters. And any single device is more than 6 meters. Other important thing. any drop line, the maximum distance of any drop line should be no more than 6 meters. No more than 6 meters per each drop line. Each drop line should be no more than 6 meters. Okay, the total distance of the drop lines, if you added all of them, should be no more than 78 in meters. And other important information is about the amount of equipment. What is the maximum? Right now we are going to talk about that. Okay, this is the picture that we checked before. And now the amount of devices. A maximum of 50 physical devices shall be connected to the network. And the disconnection of any device shall not be interrupted or shall not interrupt any other devices. Okay? And this is a typical network of configuration of the backbone. This one is perfect. You have a terminal resistor, those T's, equipment, okay, and no more than 78 meters in the drop lines, no more than 50 equipments. The maximum distance in between terminal resistor 250 for mini and mid cables, and 100 meters for micro cables. Okay, guys. Remember, no more than 50 devices in total. 50 devices, no more than 50. The maximum distance depends on the quality of the cable. If it's mini cable or mid cable, we are going to use 250 meters in between resistor and resistor, the total distance. And the total cumulative drop lines, no more than 78 meters. The maximum distance of each drop line, 6 meters. And the drop lines are part of the total distance? Yes, only if the distance in between the equipment and the T is bigger than the distance in between the T and the closed terminal resistor. If that distance is bigger, you need to add that distance into the calculation of the total distance. That's clear? This is the most important part that I need that you keep in mind. The sources of power. This is the other important thing that I need that be clear. The majority of our boats, yachts and mega yachts and pleasure boats are configured in 12 volts or 24 volts. Yes, you can configure the backbone in 12 or 24. That's your decision depending on the configuration, the specific configuration of your boat. NMEA 2000 networks can use a power supply originating from a single point connection to the vessel's 12 or 24 volts battery, or one or more isolated power supply along the network, but not a combination of battery and power supply connection. Okay, this is very important. Let me explain what is the meaning of that. In this particular example, in this particular scenario, this boat is configured with the sources of power, two sources of power coming from the battery, 12 volts. This is the particular design of this boat. There are boats that they don't use power from the batteries. They use sources of power like this. This is a source of power. The input is AC power, and the output is a controlled sources of power. I can control 12 volts here, or 6 volts, or 24 volts, constantly in between the positive and the negative. This is a constant source of DC power. In some boats, the engineers prefer install constant sources of DC power. I prefer from the batteries, because those constant sources of DC power depend of AC sources of power. Depend of the generators. In that case, I prefer install from those. The recommendation is no combinations. Okay, if all of the input of powers are from batteries, should be from batteries. If all of the input of power are from sources of power, use sources of power. That's your decision. All right. This is very, very, very important. There are other sources of power with the input coming from DC, And this is basically a regulator. Those sources of power, like the source of power that you have on the screen, are accepted and are highly recommended. Okay, that's your decision, depend what you prefer. The most important part is, don't forget, my friends, don't forget, in the backbone, no more than 8 amps. This is critical. This is in my opinion where the majority of the technicians make mistakes, introducing more than 8 amps. Immediately the computer, the main screen start with a check engine light similar with the attenuation. That's critical. I recommend be careful with the sources of power. Install the fuses with no more than 4 amps each one. If you have two sources, if you have 3 sources, you can install fuses of 3 amps or 2 amps, depending how many sources of power you install in total in the backbone. If the backbone is bigger than 100 meters, the recommendation is 1 source in the middle and 2 sources at each end in order to keep the balance on the backbone. Okay, those are the typicals connector for backbones. This one, the black and red, is exactly like this, black and red. There are other ones with the middle, with the T or yellow color for sources of power. Let me explain something. For example, this is the computer. The computer of the autopilot have in the back one cable connected for data and the other cable for power. In other words, this computer suction the power, one cable for power here, and other cable here for data. What is the meaning of that? This computer draw the power, draw the voltage from the backbone. This is possible only if the requirement of intensity is no more than 1 amp. If this equipment needs more than 1 amp, this equipment should be connected externally to the DC panel. Right now I am going to explain what is the meaning of that. Okay, the majority of the equipment, they have one cable for data and the other cable of power, like this. Normally the people, in order to avoid confusion, they put one cable in one color and the other one black, red, or yellow for power. That's decision. But in this moment, one of these is working with the power and the other one with the data for this screen. The same with other equipment. But right now, I am going to explain what happened with the power when the equipment suction the power from the backbone. Depend on the equipment, and right now I am going to explain what is the meaning of that. Okay, what is the meaning of that? Dedicated power cables. There are equipments, for example, the VHF radio. The VHF radio, the consumption in amps is more than 5 amps. And the rule is, if the equipment needs more than 1 amp, the equipment should be connected directly into the panel, not to the backbone. The power, not the data, the power. We are going to talk later about the radio and how to connect the data to the backbone and the power directly in one breaker of the DC panel. Okay? All right. If the equipment requires more than 1 amp, the equipment should be connected in one breaker here. If the equipment, the consumption in amps is less than 1 amp, shall be or could be connected into the backbone. All right. Although the NMEA cables have their own power source, some electronic devices require a separate source of power. Like I explained here, for example, this is the radio, and the power is connected here into the DC panel. And this is another equipment, and the consumption is more than 1 amp, should be connected to the DC panel in other breaker. And the backbone receive the power from the batteries with a fuse integrated here. If you have only one source of power in this backbone, that fuse should be 8 amps. 8 amps in order to protect the backbone. Okay, good. Now we are going to check. Look at this. A power tab T is connected to the network backbone, used like a T but rather than connecting a device, the purpose is provide power. Look, this one is a yellow color and the function is provide power. But you can use other ones, regular like this. Look, this one is a regular cable for power, black and red, and I connect into the T and I introduce the T in the backbone, and right now my power enter in this cable, and the color is black, but I have two cables, one positive and one negative, the negative to the negative bus bar, and the positive with a fuse into the DC panel. That's for power. All right, and those are, look, this is the voltage supplier, minimum and maximum voltage. Okay, pay attention. If the network, if the backbone is for about 12 volts, the voltage in the backbone should be minimum 9 volts and maximum 16 volts if the system is for 12 volts. If the system is for 24, the minimum should be 20 and the maximum 28. All right, this is the most common for 12 volts. Okay, and right now, isolated power supplies, unit like this in order to supply power. One or more isolated 15 volts power supplies may be connected directly to the backbone power insertion points. Multiple power supplies may be used to create multiple power insertion points for redundancy in order to keep the voltage stable. Yeah, I explained before, you can use sources of power like this, or you can use the power coming directly from the batteries, but never combine both of them. Okay, power in the middle of the network. A middle powered network is typically found on large vessels and is any network where the power is connected to the network at some locations other than at the end. This network consists of two legs, one leg extending for each direction of the backbone. Yes, this is the typical configuration. The power enters here in the middle, and one source goes over there and the other one goes over there, each one with 4 amps in total 8 amps. But I prefer, if the boat is a big boat, install one source in the middle and other source in each end in order to keep the voltage stable and in order to avoid excessive voltage drop. And right now we are going to talk about the voltage drop and what is the meaning of that. Okay, but in order to understand the voltage drop, let me clarify one important concept, the concept of length, load equivalence number, length. In order to calculate the voltage drop of the backbone, we are going to use the load equivalent number, length, that represent the integer multiples of 50 milliamps drawn by the device. What is the meaning of that? We are going to verify in the label of the equipment how much are the lengths of that equipment, and according with those lengths, we are going to know if that equipment can be, the power of that equipment can be connected directly on the backbone, or if that equipment requires a separate breaker on the DC panel. Let me explain what is the meaning of that. Okay, devices with no electrical connection other than the NMEA 2000 interface that draw more than 1 amp shall not draw power directly from the network backbone, but shall be powered from a separate breaker on the DC panel, like I explained before. In this particular case, the consumption of this equipment is 0.3 amps, is less than 1 amps. For that reason, this equipment can be connected the power directly into the backbone. And let me explain what is the meaning of that in this example. For example, suppose that I have a device that in the label electronic device, marine electronic device, and that marine electronic device in the label said 150 milliamps. What is the meaning of that? The meaning of that is that this equipment have 3 lengths, because each length, one length is equivalent to 50 milliamps. 50 milliamps. This equipment is 150, is 3 lengths. Let me check this one, 151. Is 4 lengths, because it's 3 plus 1. Okay, 4 lengths. The maximum power that a device may draw from the backbone is 1 amps. 1 amps is 20 lengths. Is 50 times 4 is 20. Okay, perfect. The maximum length in order to be connected directly into the backbone is 20 lengths. If the equipment is 20 lengths or less, can be connected directly into the backbone. If the equipment is more than 20 lengths, should be connected, the power, directly into the panel with one breaker dedicated for that equipment. For example, VHF radio, breaker, the label VHF radio, and the power directly from the panel. The radar, you know, the mechanism of the radar is the consumption is more than 5 amps. Okay, that equipment, that unit should be connected directly to the panel. The power, the data to the backbone, but the power on the panel. Be careful with that. Okay, and now we are going to use one simple formula in order to calculate the voltage drop. You can calculate the voltage drop, but in general, when you have problems of a voltage drop, excessive voltage drop, you have one code on the computer, and the code is attenuation. What is the meaning of that? The voltage drop is superior than the recommended voltage drop. Right now we are going to check what is the recommended voltage drop. Is 1.5 volts of difference. Or the NMEA 2000 network is designed to work properly as long as there is no more than a 1.5 volts difference in the power supply voltage between any two devices on the network. Therefore, you should perform an estimate of the voltage drop across the network using the following equation. The equations state this. Let me explain better in this equation. Voltage drop should be equal to 0.1 times the network loads, the length, times the total length of the backbone, times the cable resistance, and all of this divided by 10. This is a simple formula. Okay, 0.1 times the length, the total length, times the total distance, and divided by the cable resistance. Normally the cable resistance is, you remember, is 50 ohms, depending on the cable. Okay, is the network loads is the sum of the lengths. Perfect. The length is in meters, no feet, sorry, it's in meters. The total length, and the cable resistance is in ohms per each 100 meters. All right, but if it's a little confused, use the formula. You don't need to use the formula because the computer, the main screen, always show to yours if you have problems of excessive voltage drop, because immediately you have a code, and the code says attenuation. If you have attenuation, it's because the voltage drop is superior to 1.5 volts. Okay, possibilities for excessive voltage drop. Probably, according with my experience, in the majority of the cases, there are more than 50 equipments connected. Somebody installed a couple of weeks ago an additional equipment and pass the limit of 50 equipments. This is one possibility. Other possibility is the total cumulative drop lines is more than 78 meters. You need to check the distance of each equipment to the backbone, add it, and verify. Oh, I have 83. Yeah, this is the attenuation. You have excessive drop distance. Okay, and other possibility is that the voltage coming, the sources of power are not appropriately distributed on the backbone. I have only one source of power at the end of the backbone. And how is the total length? Oh, the total length is 150 meters. Oh yeah, papi, it's too long with only one source of power. I recommend, in that case, put the source of power in the middle, and probably immediately you solve the inconvenience of attenuation. Or divided two sources of power, one in each end. That's better. That's other solution. And immediately you solve the problem, because calculate, according with my experience, is difficult, because if suppose that you have mini cables, for the trunk, and mid cables for the drop lines, and you need to calculate the total and the cable resistance. You have different cable resistance, and you don't know what exactly is that amount. For that reason, I prefer, according with my experience, follow the recommendation of the computer. When you have a code, you have three possibilities: too much equipment, too much voltage drop, too much drop distance, and or the distribution of the power is not equal. It's not appropriate. You need divided the source of power in one in the middle, or two, one in each end, or three, one in the middle and two at the ends, in order to stabilize the voltage on the trunk. This is my recommendation. Okay, power supply voltage drop estimates resulting in less than 1.5 volts across the entire network require no further analysis. Okay, estimates ranging in between 1.5 voltage drop and 3.0 voltage drop require analysis and diagnosis. Okay, that's that. There are today the networks. If you enter in the display and you check the attenuation problem, they said excessive voltage drop. The voltage drop is 1.3 volts, or is 1.8. Okay, if it's 1.3, it's not critical. But if it's 1.8, it's superior to 1.5, and you need pay attention and try to solve the situation. Probably with other additional source of power, you solve the problem. Okay, be careful with the intensity. You can add more sources of power, but no more than 8 amps. No more than 8 amps on the backbone. Be careful with that. This is critical. For that reason, the introduction of the fuses is very important. Okay, my friends, and those are the ground. Once again, I repeat from the beginning of my videos, and I am going to repeat again and again all the time, is the ground. The majority of the problems, especially in electronics, is bad ground, loose ground, corroded ground, or excessive electromagnetic interference, especially here, or excessive noise, or excessive radiation. This is because the ground is not appropriate. Okay, my friend, be careful with the ground bus bar and the bonding bus bar. The ground bus bar and the bonding bus bar. Okay, you remember on the shield cable, the cable that you have on the screen right now, the bare cable, that cable should be connected to the bonding, it's drained. And the negative of the power supply cables, like this, this is the negative and this is the positive. The negative should be connected to the negative bus bar, the black cables, or yellow. And the other one, the green, in that bus bar, you remember in our class of electricity, are connected the drain cables. Okay, this is critical, my friends. The majority of the problems here in the electronics equipments are related with bad ground, with a contaminated ground, with the excessive electromagnetic interference around the backbone. 90% of the problem that I solved with the backbones is because the customer complains about attenuation code on the display, and interference code on the display. And when I visit the boat, immediately I check where is located the backbone. Oh, the backbone is here. Okay, nice, it's nice. Excuse me, what about that equipment in that corner? Oh, it's a new air conditioning equipment. We installed that air conditioning equipment a couple of weeks ago. Oh, yeah. Okay, my friend, this is the problem. Where is the ground bus bar of the backbone? Ah, it's here. It's separated 2 feet from the air conditioning equipment. Excessive electromagnetic interference. Normally, when the people install additional air conditioning equipment, immediately introduce too much electromagnetic interference around the backbone, especially around the ground bus bar. The ground bus bar should be protected and isolated. I forget explain at the beginning of this video this ferritic protection connector. That ferrule or ferritic connection is like a magnet. If you open this ferritic element, it's a negative and positive, and is covered the power of the cable in order to avoid introduce interference and noise into the LAN. All the power cables and all the data cables, all the NMEA cables should be covered with this ferrule or ferritic protection. All the cables, NMEA cables should be protected with that ferrule or ferritic protection. That protection avoid electromagnetic interference on the cable. That's very important. Okay, that's the term. Okay, right now we are going to check the summary of this video. And we are going to check all the recommendations in one slide. Okay, the first one. The number of devices should be no more than 50. The maximum mini cable between any two devices should be no less than 150 meters. I make a mistake in your book, please. It's 250, not 200. The maximum micro distance should be 100 meters. The maximum cumulative drop lines should be no more than 78 meters. Any drop line should be more than 6 meters. Perfect. The terminal resistor should be installed at both ends. Perfect. The network should be grounded in a single location. The shield will be connected to a single point on the bonding systems. This is the recommendation. Other recommendation during the troubleshoot is this: more or less than two terminal resistors are not recommended. The recommendation is one terminal resistor at the beginning and other at the end, no more. Other common problem with the backbones and NMEA connection is loose connections. Make sure that all the connectors, verify that all the connectors are properly tied, properly installed, no loose. Loose connectors avoid the introduction of moisture, and the moisture is the enemy of those cables. Excessive trunk line length, especially with micro cable, that's very common. Excessive drop line cable length, and proper shield and ground connection. Yeah, I explained before. Short and open in-field attached connector. Yeah, Mickey Mouse terminals, wrong connections, wrong crimped. You need a crimped and heat shrink. And other important thing. Oh, I forget that. Let me explain that situation. I'm going to explain in the next coming videos because right now we are going to start to explain in details autopilot, transducer, radar, all of the system one per one, and I am going to explain how is the procedure to install those equipments and the troubleshoot per each one. For example, I want to connect this cable directly into the computer, directly into the terminals. The recommendation is immediately you remove the plastic, soldering that terminal, with the soldering gun, and after that is easy introduce to those cables. And after that you don't have loose wires around, and you don't have the possibility of interference. When you remove the plastic in electronic cables, soldering the ends. That's my recommendation. This is important. If you want to crimp a terminal, okay, remove the plastic, solder in the end, put the terminal, crimp it, and heat gun with the heat string. Soldering is critical. It's important in marine electronic installations. Okay, excessive trunk line, excessive drop line, and proper sheet and ground, short and open in-field attachable connectors, failure to perform power distribution calculation. Yeah, I explained before that, using a typical device current rather than a maximum current for power distribution. Yeah. All right, my friends, this is the typical troubleshoot. I hope that you enjoy this video.